This unit applies some of our Module 2 time value of money formulas. I'm going to do some bond pricing examples today. And before we get started, just remember the basic idea. The value of any asset is the present value of the cash flows it generates. So our goals for this unit, we want to price a bond with annual coupons. We want to price a bond with a semi-annual coupon. And then understand the concept of bonds trading at a premium or a discount, which sort of goes along with the pricing idea. Well, here we have an example for an annual coupon bond, so hit pause and read the example. So if we think about pricing a bond, there's sort of two components to it. You get paid coupons, and then when the bond matures, you get a face value back or a one-time payment. So our coupons are really like an annuity. So it's a repeated cash flow until the bond matures. So here we have a 5-year coupon that will be paid to us, because the bond matures in 5 years, and at the end of the 5th year we'll get a lump sum or one-time payment of $1,000, which is the face value. So really when we price this bond, we have the present value of an annuity plus the present value of the lump sum. So the first thing is let's get the cash flows. So the coupon rate's 12% annually, and the face value is $1,000. The way we determine the coupon rate is we take the coupon rate times the face value. That gives us the dollars that we get paid. So here is 12% times 1,000, or $120 per year. Now keep in mind, the cash flows a bond pays in almost every case never change. So this bond will pay you $120 per year until it matures. That's not variable, that's fixed. The face value that you get at the end of the 5th year is $1,000. That's fixed or locked in. So the only way for you to get a greater return or a smaller return is for the price of the bond to change today. The cash flows aren't going to change. So you're going to get what you're going to get. You're going to get $120 for 5 years, and you're going to get $1,000 at the end of the last year. Oh, phone, better hit pause. So we see the full equation below. We have the present value of the annuity portion, and then the present value of the lump sum. If you look at the annuity portion, we have $120 in as the coupon payment. We have 5 in because that's the number of years until maturity. Then we have 8% as the discount rate. The discount rate is the bond's yield to maturity. This is the return investors want today, in today's market, to buy the bond and hold it until it matures. So they want an 8% annual return. This is the part of the bond that can change. Investors tomorrow could decide they want more or they could want less. That's why bond markets are very active and interest rates vary consistently. We have to be on top of it. So here's our buy-hand equation to get the price of the bond. Well, financial calculator, N is just the number of payments, I is the interest rate, payment is the coupon payment, FV or future value is the face value of the bond. We compute the present value, we get $1159.71. Now when you do this on a calculator, it'll show up as a negative for the price of the bond, so you'd get negative $1159.71. But that's just the calculator telling you this is what I would have to spend or invest today to receive these cash flows over the next 5 years. I also have the Excel formula if you're interested. Now with semi-annual, we have basically the same idea. We're going to calculate a coupon, but we just need to recognize that the coupon is going to be paid twice a year or every 6 months. We also need to think about converting our years into 6-month intervals. And we need to convert our discount rate into a 6-month rate. Everything else is the same. It's still the present value of an annuity plus the present value of a lump sum. So here, let's start with the interest rate. It says our yield to maturity is 8% per year. Since a semi-annual bond, we need to divide by M, where M is 2, to get a 6-month rate. So it would be 8% over 2, or 4% every 6 months. The coupon is paid every 6 months, so we take 12% times 1,000, and we just break it into 2 equal payments for the year. So it would be 120 over 2, or $60 every 6 months. Notice our by-hand equation, wherever you saw an R, now there's a prime. Wherever you saw a T, now there's a T prime. So everything else is the same. So here's our by-hand equation. Notice the coupon's cut in half, the interest rate's cut in half, and the number of payments is doubled. So we solve this with a financial calculator. And when we solve this, we get 1162.22, which if you look back to our previous slides is about $3 higher. So the question is, why is the semi-annual bond priced higher, or why is it priced more? Well, the reason is you get your coupons sooner. So there's more value in that when the bond's trading at a higher price. So I get $60 every 6 months instead of waiting a whole year to get $120. Well, why does that matter? Well, it just means that the first $60 gets invested in an additional 6 months. We can calculate an effective rate on the bond. You just take your 4% you get every 6 months. Remember how we do an EAR. We take 1 plus the periodic rate raised to the m minus 1. Well, here we'd say 1 plus 4%, and we'd square it because there's 2 6-month periods in a year. So 8.16 is the effective rate. Now, discounts and premiums. It's just bond vocabulary or terminology I want you to know. First, if a bond's coupon rate is greater than the required rate of return, we say the bond is trading at a premium. It's a premium because the bond pays in cash greater than what people actually need. So remember, the only way a return on a bond can adjust is if the price adjusts. So when people need less than what the bond's actually paying out, the price goes up because investors are getting more than they need. On the flip side, if a bond's coupon rate is less than the required rate of return, the bond is trading at a discount. So in other words, it's on sale. If you think about the face value of $1,000 as the retail price of a bond, or the fair price, if investors think the bond is risky or riskier, they'll pay less than $1,000. So it trades at a discount or a price less than full price. Let's look at the following example. So we just did a bond trading at a premium. Let's do one trading at a discount. Here we're looking at a bond with a coupon rate of 7.25% that matures 7 years from today. It says we're required, or we want to earn 9% on this bond. That's our yield to maturity. What's the maximum price we'd be willing to pay for this bond if it pays coupons annually or semi-annually? Well, I'm going to do the annual example, and then I'll probably let you look through the slides to do the semi-annual. But let's go through the steps again. First step, let's take the coupon rate and convert it to dollars. Let's apply our by-hand equation. Remember, it's the present value of the annuity plus the present value of the lump sum, using our discount rate or yield to maturity of 9%. So N is 7 for the number of years. I is 9% for the annual discount rate. Payment is $72.50. That's 7.25% times 1,000. Future value is 1,000. We compute the present value as $911.22. Let's go ahead and do the semi-annual while we're here. We double the number of payments to 14, so we have an M prime there. We'd cut the interest rate in half because it's across 2 6-month periods. So 9% divided by 2 is 4.5. We'd cut the payment in half. So instead of $72.50 for the year, it's 2 payments of $36.25. And then we use the same future value of 1,000. We solve for the present value of $910.55. So notice when bonds are trading at a discount, the semi-annual bond trades at an even lower price.